Tonight, we're going to explore the largest comet we have ever found in the universe. This is not something you need to understand all at once. The numbers we will discuss are vast, and the distances are beyond what the human mind was designed to hold. You don't need to remember every detail or keep track of every kilometer. You can simply listen and allow your thoughts to drift. As we move slowly outward, away from the warmth of the sun and into the quiet, frozen reaches of the Oort cloud. To begin, let's start with something familiar. Imagine, if you will, the sensation of a cold winter evening where the air is still and the world seems to have paused its frantic pace. In this stillness, there is a clarity that only comes when the noise of the day subsides. We are looking upward, past the rooftops and the sleeping trees, toward a faint smudge of light that has traveled for millions of years just to meet your gaze. This visitor, Bernardinelli Bernstein, is a relic from the dawn of time, a silent witness to the formation of everything we have ever known. It does not demand your attention, it simply exists, carving a slow, deliberate arc through the velvet dark. As we begin this journey, feel the weight of your body settling, much like the ancient dust settles on the surface of a distant moon. There is no rush here. The universe operates on a clock that does not count seconds, but eons. To understand this comet, we must first let go of the need for speed. We must adopt the patience of the vacuum. Astronomers spent years scanning the deep sky before they realized what they were seeing was not a star, but a giant, a wandering mountain of ice and stone that challenges our very definition of what a comet can be. It is a quiet revelation, one that doesn't startle, but slowly settles into the mind. What makes this discovery so profound is not just its size, but the way it reminds us of the hidden structures that surround our sun. We often think of the solar system as a collection of neat, orderly planets, but beyond them lies a vast, chaotic fringe where billions of these icy bodies drift in a perpetual twilight. Tonight, we are going to bridge that gap. We will move from the familiar warmth of your room to the crystalline silence of the deep void. You are safe, you are grounded, and the universe is simply opening its doors a little wider to show you something magnificent. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. When we think about a comet, we often imagine it in human terms. Perhaps you picture a dirty snowball, something you could hold in your hands, or a mountain floating in the dark. We measure time in years, and we measure distance in how long it takes to walk to a neighbor's house. If you were to walk across a typical comet, like the famous Halley's Comet, it would take you a few hours. It is a small island in a very large ocean. Astronomers call them primitive bodies, leftovers from the construction of our solar system, like the scrap wood left on a workshop floor. But the object we are discussing tonight, Comet Bernardinelli Bernstein, challenges this scale. If a typical comet is a pebble, this object is a boulder. If a typical comet is a small hill, this is a mountain range that has decided to take a very long walk through the vacuum of space. This comparison isn't perfect, but it gives us a calm place to begin. To truly grasp the magnitude of Bernardinelli Bernstein, we must first look at the things we encounter in our daily lives. Think of the tallest building you have ever stood beside. Perhaps it was a skyscraper in a bustling city, a structure that required you to tilt your head back until your neck ached just to see the summit. To a human, that building is immense. Yet, if you were to place that skyscraper on the surface of this comet, it would be nothing more than a microscopic grain of dust, invisible to the naked eye. We often use the word mountain to describe large things, but even the mountains we hike, the ones that take days of physical exertion to summit, are dwarfed by this wandering titan. If you were to stand at one edge of Bernardinelli Bernstein and look toward the other, the curvature of the horizon would be so gentle that you might forget you were on a floating island at all. It would feel like standing in the middle of a vast frozen plain that stretches on for nearly 85 miles in every direction. Consider a journey across this object. If you were to drive a car at a steady highway speed from one side of the nucleus to the other, it would take you well over an hour of continuous movement. During that hour, you would pass nothing but ancient, pristine ice and dark, organic compounds that have remained undisturbed since before the Earth was fully formed. In our world, a city that spans 80 miles is considered a megalopolis, a sprawling network of life and infrastructure. Here, in the silence of space, that same distance is occupied by a single, monolithic block of primordial material. This is not just a comet, it is a celestial province. It is a mass so significant that it possesses its own gravitational personality, a subtle pull that, while weak compared to a planet, is a powerful reminder of how much matter has been gathered here in the dark. Historically, humans have looked at comets with a mixture of fear and wonder. To a medieval observer, a comet was a hairy star, a localized omen that occupied the same sky as the moon. They assumed these objects were small, perhaps atmospheric phenomena like clouds or lightning. They had no way of knowing that some of these visitors were larger than the very kingdoms they lived in. If Bernardinelli Bernstein had passed through the inner solar system during the Renaissance, it would not have appeared as a mere streak in the sky. Its coma would have occupied a vast portion of the night, a glowing shroud so large it would defy the explanations of the era's greatest minds. They measured their world in the distance a horse could travel in a day. To them, the idea of a single rock 80 miles wide would be as inconceivable as the idea of the vacuum itself. When we speak of primitive bodies, we are acknowledging that this comet is a time capsule. On Earth, everything is constantly recycled. Mountains erode, tectonic plates shift, and the weather polishes the surface of the planet until the original history is wiped clean. But on a comet of this scale, the history is preserved in a deep cryogenic freeze. The center of Bernardinelli Bernstein is likely composed of the same material that existed when the Sun was a young, flickering star surrounded by a disk of gas. To touch its surface would be to touch the very beginning of our story. We are talking about a mass that has remained largely unchanged for 4.5 billion years. It has been drifting in the outer reaches, far beyond the reach of the Sun's eroding heat, maintaining its gargantuan proportions while the planets were still busy colliding and forming their crusts. In our modern lives, we are used to things being temporary. We build, we consume, and we move on. But this object represents a different kind of existence, one defined by endurance and scale. It reminds us that our perspective is limited by our biology. We see the world in meters and kilometers because that is the scale at which we operate. But the universe operates on the scale of Bernardinelli Bernstein. It creates giants in the dark and sends them on journeys that last millions of years. This comet is a reminder that even in the empty parts of our solar system, there are structures of such staggering size that they make our largest engineering projects look like toys discarded in a sandbox. As we sit here tonight, safe in the soft light of our homes, it is comforting to think of this giant. It is not a threat, it is a sentinel. Its size is not something to be feared, but something to be admired, like the depth of an ocean or the height of a canyon. It exists, far away, moving with a grace that only comes from having immense mass and infinite time. It is a boulder in the cosmic stream, and as we drift closer to sleep, we can imagine ourselves shrinking down, becoming small enough to appreciate the true majesty of this mountain that flies. We are leaving the human scale behind now, moving away from the cars, the cities, and the skyscrapers, and stepping into the realm where 80 miles is just the beginning of the story. To bridge the gap between our world and the home of the giants, we must first look at the things we can touch, measure, and walk upon. In our daily experience, an 80-mile journey is a commitment. If you were to set out on foot at a brisk pace, it would take you several days of constant walking to cover that distance. You would cross county lines, pass through dozens of neighborhoods, and see the landscape shift from hills to plains. On Earth, 80 miles is a vast expanse of geography. But in the context of Comet Bernardinelli-Bernstein, that entire journey, every step, every mile, is contained within a single, solid object. It is a monolithic island of ice, so large that if you stood at its center, the horizon would curve away from you with the same slow, inevitable geometry as the planet itself. When we speak of comets as dirty snowballs, we are using a metaphor that fits a human hand. We imagine something we could scoop up from a winter driveway. But this object is a dirty skyscraper, or, more accurately, a dirty mountain range. If you were to place this comet on a scale, its mass would be so profound that it would defy our standard units of measurement. We are talking about trillions of tons of ancient material. Yet, despite this staggering weight, it moves through the vacuum with a weightlessness that is almost impossible to reconcile with its size. It is a heavyweight champion performing a slow-motion ballet in a room with no floor. This contrast between the immense solidity of the comet and the ethereal lightness of its movement is one of the most calming aspects of the deep cosmos. Consider the history contained within those 80 miles. Everything on our planet is subject to the relentless erosion of wind, water, and life. Our mountains are ground down, our cities are rebuilt, our very soil is turned over by the roots of trees, but the surface of this comet is a landscape of absolute preservation. To walk across it would be to step onto a floor that was laid 4.5 billion years ago. The craters you would find there are not just holes in the ground. They are signatures of the early solar system's chaotic youth, preserved in a deep freeze that has never thawed. There is a profound sense of safety in this kind of permanence. While our world is a place of constant, sometimes exhausting change, the comet is a sanctuary of stillness. It is a physical record of where we came from, held in a dark, quiet grip. Historically, humans have used comets to mark the passage of great events, usually with a sense of urgent superstition. We saw them as temporary flashes, streaks of light that belong to the atmosphere rather than the stars. But Bernardinelli-Bernstein challenges the very idea of a flash. Its presence is a slow, enduring fact. If a medieval astronomer had possessed the tools to see it, they would have watched it for their entire life without seeing it move more than a fraction of an inch against the stars. It is a reminder that the hurry, of human history is a localized phenomenon. Beyond our thin layer of air, the universe operates with a leisure that we can barely conceive. The comet does not hurry because it has no reason to. It is the master of its own time. As we move further away from the human scale, we can begin to appreciate the sentinel nature of this object. It is like a lighthouse at the edge of a vast, dark ocean. Its purpose is not to warn us of danger, but to mark the boundaries of our home. When we find an object of this size, it changes our map of the neighborhood. It tells us that the solar system is much larger, much fuller, and much more majestic than we previously realized. We are not living in a small, empty room. We are living in a sprawling estate, and Bernardinelli Bernstein is one of the grandest monuments on the far reaches of the property. Imagine shrinking down until the room you are in feels as large as a galaxy. Your bed becomes a planet. Your blankets become vast nebulae of soft, warm fabric. In this state of mind, the comet is no longer a distant scientific fact, but a nearby companion. It is a boulder in a stream, and we are the water flowing past it. We can feel the stability of its mass. It is a solid point in a fluid universe. This feeling of solidity is essential for deep rest. When the world feels too fast or too thin, we can anchor our thoughts to the 80-mile-wide heart of the comet. It is a place where nothing can be broken, nothing can be rushed, and nothing is ever lost. The mountain that flies is a beautiful contradiction. In our experience, mountains stay put. They are the definition of grounded. But in space, the most grounded things are also the ones in constant motion. The comet is grounded by the gravity of the sun, even as it travels through the void. It is a part of a system that is perfectly balanced, perfectly calculated, and perfectly safe. As we leave the cars and the skyscrapers behind, we are entering a realm where the rules are simpler. There are no traffic lights in the Oort cloud. There are no deadlines in the Kuiper belt. There is only the long, slow arc of the Sentinel, moving through the dark with a grace that we can now begin to claim as our own. You are small enough now to see the true majesty. You are small enough to let the comet be the large thing while you remain the quiet, resting thing. The 80 miles of its width are not a distance you have to travel. They are a distance you can simply acknowledge. It is a landscape of peace, a province of silence, and a monument to the endurance of the universe. The cars have stopped, the cities have dimmed their lights, the skyscrapers have receded into the haze. You are in the realm of the long-period wanderer, and the story is only just beginning. Now, let's slowly expand outward. One level beyond what we just explored lies the moment of discovery. Scientists understand the scale of the universe by observing minute changes in light over long periods of time. In 2014, while looking at data from the Dark Energy Survey, astronomers noticed a tiny point of light. It was moving, but so slowly that it took years of observation to realize it wasn't a distant star or a galaxy. What we know so far suggests that this object, C 2014 UN 271, is roughly 85 miles across. To put that in perspective, if you were to place this comet on the ground, it would cover the entire state of Rhode Island and still have room for a few extra towns. But even with everything we've learned, there are still things we don't fully understand. We see its size, but we do not yet know its exact composition. Is it a solid block of ancient ice? or a loose collection of dust held together by the faintest hint of gravity. Not because we're missing something urgent, but because the universe moves slowly over immense spans of time. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. With that in mind, let's move outward once more, to an even larger scale. To appreciate the discovery of Comet Bernardinelli-Bernstein, you have to imagine the sheer volume of data that astronomers sift through every single night. The Dark Energy Survey wasn't even looking for comets. Its primary mission was to map hundreds of millions of galaxies, peering billions of light years into the past to understand the expansion of the universe itself. But the cosmos is layered. While we look at the distant shore of the deep universe, things are drifting much closer to home. It is like looking through a telescope at a distant mountain range and suddenly noticing a tiny insect crawling across the lens. Only, in this case, the insect is a mountain of ice, 85 miles wide, and it is moving through the outer suburbs of our solar system. For 6 years, this object remained a ghost in the machine. It appeared in images taken between 2014 and 2019, but it was so far away, nearly as far as Neptune, that it looked like nothing more than a static pinprick of light. It took the dedicated work of Pedro Bernardinelli and Gary Bernstein to apply sophisticated algorithms to this massive data set, tracking the subtle shift of that single point against the background of fixed stars. Think of the patience required for such a task. It is the digital equivalent of watching a glacier move from a mile away. You cannot see the motion in real time. You can only see where it was and where it has arrived. When the calculations were finally completed, the scientific community felt a collective sense of quiet awe. Most comets that venture into the inner solar system are the size of small villages, perhaps 2 or 3 miles across. When a 10-mile wide comet appears, it is a once-in-a-generation event. But 85 miles, that is a measurement that feels almost illegal in the context of cometary science. It shouldn't be there, and yet, there it is, a dark titan emerging from the gloom. If you were to drive a car around the circumference of this comet's nucleus, it would be a journey of over 260 miles. You would be driving for hours through a landscape of frozen methane, ancient dust, and water ice that hasn't felt the warmth of a sun in millions of years. The discovery was not a eureka moment of flashing lights and sirens. It was a slow dawning of reality. The data showed that this object wasn't just large, it was exceptionally fresh. Most comets we see have been baked by the sun many times, their surfaces scarred and depleted of their original gases. But Bernardinelli-Bernstein is a traveler from the deep freeze. It is arriving with its primordial coat intact. This makes it a scientific treasure, a pristine sample of the ingredients that cooked in the solar nebula billions of years ago. We are looking at a giant that has been kept in the back of the freezer since the very first day the kitchen opened. As we sit with this thought, we might wonder what else is out there, still hidden in the data. The universe is a very large place, and our eyes, even our digital ones, are very small. We only found this giant because it was large enough to reflect a tiny bit of sunlight back toward our telescopes. There may be others, even larger, still drifting in the shadows of the Kuiper belt or the inner Oort cloud, waiting for their turn to be noticed. But there is no hurry to find them. The universe is patient, and the data will be there when we are ready to look. The mystery of its composition remains one of those beautiful, open questions. Is it a rubble pile, a collection of boulders and dust, barely holding on to one another in a delicate gravitational hug? Or is it a solid, crystalline heart of ice, as hard as granite and as cold as the void itself? We don't know yet, and that is okay. We can visualize both possibilities as we drift towards sleep. We can imagine the jagged cliffs of ice or the soft, powdery slopes of cosmic dust. Both are equally silent. Both are equally ancient. In the history of astronomy, we have often been surprised by the scale of things. We once thought the Earth was the center of everything. Then we thought the Sun was the center. Then we realized our galaxy was just one of billions. Every discovery of a giant like this comet is a gentle reminder that we are still in the early chapters of the book. We are still learning the true dimensions of our own backyard. As we move outward in our minds, past the orbit of Neptune and into the scattering of the outer reaches, we can feel the comfort of that vastness. There is so much room for these giants to roam. There is so much space for them to exist without ever crowding us. The comet is currently on its way in, but in is a relative term. It will never get closer to the Sun than the orbit of Saturn. It is keeping its distance, a polite visitor that doesn't want to intrude. It will flare up, its coma will grow, and it will eventually become a bright target for our most powerful telescopes, but it will remain a distant, silent observer. We have years to watch it. We have decades to study it. There is no urgency in the cosmos. Everything happens in its own time, governed by the elegant, slow-moving laws of orbital mechanics. As we conclude this first loop of scale, let your mind settle on that 85-mile-wide nucleus. Visualize it as a dark, silent island in a sea of nothingness. It is moving toward us, but so slowly that it will take another decade just to reach its closest point. It has all the time in the universe, and for tonight, so do you. You are part of a world that can find such things, that can look into the dark and see the giants moving there. It is a quiet, contemplative thought to carry with you. With that in mind, let's move outward once more, to an even larger scale. One level beyond what we just explored lies the moment of discovery. Scientists understand the scale of the universe by observing minute changes in light over long periods of time. In 2014, while looking at data from the Dark Energy Survey, astronomers noticed a tiny point of light. It was moving, but so slowly that it took years of observation to realize it wasn't a distant star or a galaxy. What we know so far suggests that this object, C 2014 UN 271, is roughly 85 miles across. To put that in perspective, if you were to place this comet on the ground, it would cover the entire state of Rhode Island and still have room for a few extra towns. But even with everything we've learned, there are still things we don't fully understand. We see its size, but we do not yet know its exact composition. Is it a solid block of ancient ice, or a loose collection of dust held together by the faintest hint of gravity? Not because we're missing something urgent, but because the universe moves slowly over immense spans of time. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. With that in mind, let's move outward once more to an even larger scale. To appreciate the discovery of Bernardinelli Bernstein, we have to look into the way we perceive the dark. In our daily lives, discovery is often a sharp, sudden moment, a flash of a camera, the turning of a page, or the finding of a lost set of keys. But in the deep reaches of the solar system, discovery is a slow accumulation of evidence. It is a patient gathering of photons, one by one, over years of silent observation. The Dark Energy Survey was never designed to find a comet. Its primary focus was the most distant structures in the cosmos, galaxies and clusters billions of light years away, expanding into the void. But as our telescopes peer into the furthest depths of the past, they occasionally catch a glimpse of the present drifting much closer to home. It is like looking through a window at a distant mountain and noticing a tiny, slow-moving snowflake right on the glass. The digital eye of the dark energy camera is a marvel of human engineering, yet it can only see what it is programmed to recognize. For years, the data containing this giant comet sat in digital archives, a silent point of light among hundreds of millions of others. It took the dedicated work of human minds, coupled with the tireless processing of algorithms, to see the pattern. They weren't looking for a record breaker. They were looking for anything that moved against the backdrop of the fixed stars. Think of the quiet persistence of such a search. It is the work of years, not minutes. It is a process of subtraction, removing everything that stays still until only the wanderers remain. When they finally isolated C, 2014 UN 271, they realized they weren't looking at a faint star at all, but a massive object only a few billion miles away. The scale of 85 miles across is difficult for us to hold in our minds without a sense of quiet wonder. In the world of comets, anything over 10 miles is considered a behemoth. To find something 10 times that diameter is to find a visitor that defies the standard rules of its species. If you were to walk across this comet, as we imagined earlier, you would be traveling through a landscape that is physically larger than many mountain ranges on Earth. It is a world unto itself, a dark, frozen island that has its own gravity, its own topology, and its own deep internal history. We see its silhouette, but we do not see its heart. This is the mystery of the discovery. We have found the giant, but we are only just beginning to learn its name. Historically, the discovery of a new comet was a task for the naked eye or the small telescope, a hobby for the patient watcher in a backyard. But as our technology has expanded, the backyard has become the entire solar system. We are now able to find these objects while they are still in the deep freeze of the outer planets. When Bernardinelli Bernstein was first spotted, it was as far away as Neptune, drifting in a region where the sun is just a particularly bright star. Most comets are invisible at that distance. They are too small and too dark to reflect enough light. But this one was different. It was so large that it made its presence known long before it ever felt the warmth of the inner solar system. It was a giant calling out from the shadows, a sentinel that refused to be ignored. What we know so far suggests that this object is a pristine traveler. This is a term astronomers use for something that has never been cooked by the sunday. Every time a comet passes near the sun, it loses layers of its history. Its ice sublimates, its dust blows away, and its surface is scarred by the heat. But because this comet has such an immense orbit, lasting millions of years, it has spent almost its entire existence in the absolute zero of the Oort cloud. It is a time capsule from the very first days of our solar system. The discovery of such an object is like finding a perfectly preserved letter from a distant ancestor, written in a language that predates our own. It is a gift of information, delivered by gravity at a pace that respects our need for quiet. But even with everything we've learned, there are still things we don't fully understand about how it came to be in its current path. The universe is a vast field of motion, and every object in it is responding to a complex web of gravitational tugs. Was this comet nudged by a passing star 3 million years ago? Or was it moved by the subtle galactic tide, the gravitational breathing of the Milky Way itself? We see the result, the 8.5-mile wide nucleus falling slowly toward the Sun, but the cause remains an open question. This is the mild mystery that keeps curiosity alive without creating tension. It is a puzzle that stretches across light years and eons, and we are content to let it remain a puzzle for tonight. The uncertainty of its composition is another gentle thought to carry with us towards sleep. We often want to categorize things, to say, it is this, or it is that, but Bernardinelli Bernstein sits in a category of its own. It is larger than most asteroids, yet it behaves like a comet. It is a mountain of ice, yet it is as dark as coal. Scientists debate whether it is a solid, monolithic block or a loose rubble pile held together by a gravitational whisper. You can imagine both possibilities. You can visualize a solid, crystalline heart of ancient ice, as hard as diamond. Or you can visualize a soft, porous collection of dust and boulders, like a cloud that has decided to take a physical form. Neither answer changes the beauty of the object. Both are simply ways for us to try and understand the scale of the giant. As we move outward in our perspective, the discovery of the comet becomes a discovery of ourselves. It shows us that we are capable of looking into the dark and finding the hidden structures of our home. It shows us that we have the patience to watch a single point of light for 6 years just to see it move. This capacity for patient observation is a calming quality. It reminds us that we don't have to solve everything immediately. We can gather data, we can wait, and we can allow the truth to reveal itself in its own time. The comet is moving at its own pace, and we are watching at our own pace. There is no conflict in this relationship. There is only the steady, shared progression of time. Consider the 85 miles once more. It is a number, but it is also a landscape. On Earth, 85 miles is the distance between 2 distant cities. It is a journey that would take a bird an entire day to fly. On the comet, that distance is occupied by a single, silent presence. There are no roads there, no lights, no sounds. There is only the dark, ancient surface and the distant glitter of the stars. The discovery of this landscape is a reminder that the universe is far more substantial than we often imagine. It is not just empty space. It is filled with these massive, enduring landmarks. They are the fixed points in our moving neighborhood. The fact that this discovery happened now, in our lifetime, is a quiet hook of wonder. For millions of years, this comet was drifting in the dark, unseen and unknown. It passed the orbits of the outer planets in silence. But as it approached the inner realms, we were here to greet it with our digital eyes. It is a brief intersection of 2 very different histories, the 3 and 5 million year history of the comet and the few 1,000-year history of human astronomy. We are witnessing a moment that will not be repeated for another 3 million years. There is a gentleness in this timing. We don't have to do anything about it. We simply have to be here to acknowledge it. As the mind begins to drift, let the numbers and the facts start to soften. The 85 miles becomes just a vast, comfortable distance. The 2014 discovery becomes just a moment of quiet recognition in the past. The algorithms and the telescopes fade into the background. What remains is the image of the giant mountain of ice moving through the dark with a calm and inevitable momentum. It has been found, but it is still free. It has been measured, but it is still a mystery. It is a sentinel at the edge of the world, and we are the quiet observers, safe in the knowledge that the universe is much larger and much more stable than we could have ever dreamed. The uncertainty is simply part of the picture. It doesn't need to be resolved tonight. We can accept the unknown as a comfortable neighbor. We can live with the mystery of the comet's heart, just as we live with the mystery of our own dreams. Both are vast, both are ancient, and both are unfolding exactly as they should. The discovery is not an end point, it is a gateway. It is an invitation to look further, to move outward, and to embrace the scale of the cosmos without fear. With that in mind, let's move outward once more, to an even larger scale. Imagine climbing a ladder where every new rung makes the previous one look microscopic. We begin with Earth, a world that seems enormous when you are standing on its surface, with oceans covering 71% of its face and mountains rising miles into the sky. But as we zoom out, Earth begins to shrink, not physically, but in significance. It stops being everything and becomes just one thing among many. Compared to the solar system, Earth is a speck. Compared to the galaxy, the solar system is a speck. And compared to the largest structures in the cosmos, even entire galaxies are like dust. To understand this ladder, we must first appreciate the rung we are currently standing on. To an early human, the Earth wasn't a planet. It was the floor of the universe. If you were to stand in the middle of a vast, flat plain, the horizon is only about 5 kilometers away. That was the limit of your world. Beyond that was mystery. Even today, with all our technology, the sheer physical bulk of the Earth is staggering. If you were to take a commercial flight from New York to Singapore, you would spend nearly 19 hours in the air, traveling at 500 miles per hour, and you would still only have covered a fraction of the planet's circumference. We perceive the Earth as a giant because, relative to our bodies, it is. We are 6-foot creatures living on a 12,000-kilometer sphere. But now, we take the first step up the ladder. We move from the Earth to its neighborhood, the inner solar system. As we pull away, the massive continents and vast oceans we just described begin to blur. At a distance of about 1 million kilometers, the Earth no longer looks like a world. It looks like a marble, and right next to it, relatively speaking, is the Moon. We often see diagrams of the Earth and Moon close together, but the reality is much emptier. You could fit every other planet in our solar system, Jupiter, Saturn, Mars, Venus, all of them into the space between the Earth and the Moon, and you'd still have room to spare. This is our first lesson in cosmic scale. Space is mostly empty. Even the crowded parts are defined by the gaps, not the objects. As we continue to climb, we reach the rung of the gas giants. This is where Earth's ego takes its first major blow. Jupiter is so large that 1,300 Earths could fit inside it. If Earth were the size of a grape, Jupiter would be the size of a basketball. Saturn, with its magnificent rings, isn't much smaller. These are worlds made of gas and liquid, with pressures so intense they turn hydrogen into metal. When you look at Jupiter's Great Red Spot, a storm that has been raging for centuries, you are looking at a vortex that is wider than our entire planet. On this rung of the ladder, Earth has transitioned from the world to a minor rocky outpost. But the ladder doesn't stop at the planets. The next rung belongs to the Sunday. Our star is a yellow dwarf, a relatively average star, yet it contains 99.8% of all the mass in the solar system. You could fit 1 million Earths inside the Sunday. If the Sun were the size of a front door, the Earth would be the size of a nickel. At this stage, the scale of the planets, even Jupiter, starts to look trivial. The Sun's gravity is the anchor that holds everything together, reaching out billions of miles to the frozen edges of the Kuiper Belt. Yet, even the Sun is just a starting point. We climb higher, and now we are looking at the interstellar neighborhood. We are no longer measuring in miles or kilometers. We are measuring in the distance light travels in a year. The Sun, which seemed so dominant, begins to shrink into a tiny point of light. It joins a crowd of other stars, Alpha Centauri, Sirius, Vega. We begin to realize that our Sun is just one of 200 to 400 billion stars in the Milky Way. On this rung, the entire solar system, everything from the Sun to the furthest comet in the Oort cloud, is smaller than a single pixel on a high-definition screen. We have reached a level where the individual planets are literally too small to see. Now we reach the rung of the galaxy. The Milky Way is a barred spiral, a vast disk of stars, gas, and dust spinning through the void. It is 100,000 light-years across. To get a sense of this scale, if our entire solar system out to Neptune was the size of a white blood cell, the Milky Way would be the size of the continental United States. We are tucked away in one of the spiral arms, about 26,000 light-years from the center. At the heart of this massive structure is Sagittarius A*, a supermassive black hole 4 million times the mass of the Sunday. On this rung, the world we started with is not just a speck, it is an invisible ghost, an infinitesimal part of a much larger organism. But the ladder keeps going. We move to the local group. This is a collection of about 50 galaxies, including our own and our larger neighbor, Andromeda. These galaxies are bound together by gravity, dancing around each other in a dark cosmic ballet. The distance between the Milky Way and Andromeda is 2.5 million light-years. On this rung, even the 100,000 light-year span of our galaxy starts to look manageable. We are seeing galaxies not as vast expanses of stars, but as individual units, islands of light in a sea of nothingness. We climb further, reaching the rung of galaxy clusters and superclusters. We encounter the Virgo supercluster, which contains thousands of galaxies. And then we see the Laniakea supercluster, a structure so vast it defines our place in the local universe. Laniakea, which means immeasurable heaven in Hawaiian, is 500 million light-years across. It contains the mass of 100 quadrillion suns. On this rung, the Milky Way is just a tiny spark on one of the outer branches of a massive, glowing celestial tree. The ladder of scales has now taken us to a point where distance has become a concept that our brains can only process through mathematics. But there is one more rung we've discovered recently, the rung of the great filaments. These are the largest structures ever found in the universe. We are talking about things like the Hercules Corona Borealis Great Wall. This is a filament of galaxies that spans 10 billion light-years. That is about 10% of the entire observable universe. It is a structure so gargantuan that it challenges our fundamental understanding of how the universe began. According to the cosmological principle, the universe should be smooth and uniform on such large scales, yet here is a wall of matter that defies that smoothness. On this final rung, we aren't just looking at stars or galaxies, we are looking at the cosmic web, the very skeleton of reality. Think back to where we started, a 5-kilometer walk to the horizon. We have climbed from that walk to a structure 10 billion light-years long. The ratio between a human stride and the Great Wall is almost too large to write down in zeros. This is the ladder of scales. It is a journey of systematic humiliation for the human ego, but it is also a journey of profound discovery. Every time we move up a rung, we lose something and we gain something. We lose the feeling of being the center of the universe. We lose the idea that our planet is a massive, indestructible fortress. But we gain a perspective that no other known species possesses. We gain the ability to see the long view. We learn that the universe isn't just a place where things happen. It is a structured, evolving, and terrifyingly beautiful hierarchy. This ladder also teaches us about the nature of size. Size is entirely contextual. To a mountain, a human is nothing. To the earth, a mountain is a wrinkle. To the sun, the earth is a pebble. To the galaxy, the sun is a grain of sand. And to the cosmic web, the galaxy is a puff of smoke. When we talk about the largest object ever found, like the Quipu or IC 1101, we aren't just talking about big things. We are talking about the limits of structure itself. We are asking, how much matter can gravity hold together before the expansion of the universe pulls it apart? As you use this segment in your stories, remember that the ladder of scales is the ultimate narrative tool. It allows you to move the audience from the intimate to the infinite. It reminds the viewer that while their problems feel world-sized, the world itself is speck-sized. This contrast is where the awe comes from. It's the tension between our tiny, fragile lives and the massive, ancient structures that surround us. We are creatures of the first rung, yet we have built telescopes and theories that allow us to see the top of the ladder. We may never physically leave our neighborhood, but mentally, we have already conquered the Great Wall. We have mapped the Laniakea supercluster from the surface of a small, rocky planet orbiting an ordinary star. So, when you look at the night sky, try to see the rungs. Don't just see points of light. See the depth, unmere. See the moon just above us, the planets further out, the stars beyond them, and the faint glow of distant galaxies beyond those. Understand that you are standing on the bottom step of a ladder that goes on forever. The horizon isn't 5 kilometers away, it's 46 billion light-years away in every direction. And the fact that you can even conceive of that distance means that while you are physically small, your mind is as vast as the ladder itself. We have seen the scale, we have felt the shrink. Now, in the next segments, we will look at the bridge that connects these rungs, light itself. We will see how we cross these distances not with rockets, but with our eyes. The ladder is tall, but the view from the top is spectacular. To climb this ladder of scales is to participate in a systematic dismantling of our own intuition. We start with the Earth, our human anchor, where the horizon is a mere 5 kilometers away. On this first rung, we are masters of our domain. We measure the world in footsteps and hours. But the moment we look up and contemplate the lunar gap, that 384,400 kilometer chasm, we realize that our biological yardsticks are already starting to snap. If you were to drive a car at highway speeds toward the moon, it would take you 6 months of non-stop travel. If you chose to walk, you would need 9 years of your life. Already, on just the second rung of the ladder, the human scale has become a burden rather than a tool. As we ascend to the solar anchor, the numbers don't just grow, they transform. The Sun is 150 million kilometers away, 1 astronomical unit, AU. To walk this distance would take 3,500 years. We are now dealing with scales where entire civilizations could rise and fall in the time it takes to cross the gap. This is why we must transition to the most fundamental constant in the universe: light. Light is the only thing fast enough to act as a bridge across these gulfs. It travels at 300,000 kilometers per second. It can circle the Earth 7 times in a single heartbeat. Yet, even light takes 8 minutes to reach us from the Sunday. When we look at the Sun, we are not seeing it as it is now, but as it was nearly 9 minutes ago. We have begun our transition from space travelers to time travelers. The ladder takes us further into the interstellar neighborhood. Here, the Sun, a star that could hold 1 million Earths, shrinks into a tiny, flickering point of light among billions of others. We find ourselves in the Milky Way, a barred spiral galaxy, 100,000 light-years across. To grasp this, imagine the entire Earth is the size of a single grain of sand. In this scale, the Milky Way would be the size of the entire United States. Every star you see in the night sky is just a local neighbor in our small corner of this vast continental structure. We are tucked away in the Orion Arm, 26,000 light-years from a supermassive black hole that anchors our galaxy. On this rung, the individual planets are no longer visible. They are ghosts lost in the glare of 200 billion suns. But the ladder does not end at the edge of our galaxy. We reach the rung of the local group, a collection of 50 galaxies bound together by gravity. Our sister galaxy, Andromeda, sits 2.5 million light-years away. If the Milky Way is a city of light, the local group is a small cluster of towns separated by vast, dark countrysides. Beyond this lies the Virgo supercluster, a massive assembly of thousands of galaxies. And beyond that, the Laniakea supercluster, a structure so gargantuan it spans 500 million light-years. Laniakea, meaning immeasurable heaven, is a web of light where galaxies flow like water toward a gravitational center called the Great Attractor. As we reach the highest rungs, we encounter the defiant anomalies, structures that shouldn't exist. We find the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure represents 10% of the entire observable universe. Its very existence challenges the cosmological principle, which assumes the universe should be smooth and uniform on large scales. This wall is a giant knot in the fabric of space-time, a testament to the fact that the ladder of scales still has rungs we don't fully understand. We see giant circles in the cosmic microwave background and cold spots that hint at collisions with other universes or remnants from before the Big Bang itself. We also witness the monster galaxies like IC 1101. While our Milky Way is 100,000 light-years wide, IC 1101 is 6 million light-years across. It is an elliptical giant that has grown by devouring thousands of smaller galaxies over billions of years. If you placed IC 1101 where the Milky Way is today, it would swallow up Andromeda and most of our local group. It is a graveyard of stars, a terminal point in the evolution of galactic structures. At this scale, even the light that bridges the rungs takes millions of years to cross from one side of a single galaxy to the other. The ladder of scales reveals a universe that is a system of systems. Atoms form molecules. Molecules form dust. Dust forms planets. Planets orbit stars. Stars cluster into galaxies. And galaxies weave into the cosmic web. To understand the cosmos, we first have to understand our own limitations. We evolved to perceive distances we can walk in a day, or see with our own eyes distances that matter for survival and navigation. A kilometer is a 10-minute walk. A mile is a 20-minute journey. These measurements are concrete and relatable because they fit into our daily lives. But the moment we look up, these human-scaled units become awkward and eventually useless. To explore the universe, we must leave behind the familiar and prepare for a scale that challenges our very ability to comprehend it. Our brains are essentially biological survival machines, fine-tuned over millions of years to solve problems on a local scale. When our ancestors stood on the African savanna, big meant the distance to the horizon or the height of a mountain. Fast was the speed of a sprinting predator or a falling stone. We developed a deep, intuitive relationship with the physical world, but it was a world restricted to a very narrow band of reality. This is our human-scale anchor. It is the comfort zone of the tangible. In this zone, we can estimate how long it takes to drive to the next city, or how many steps it takes to cross a room. We feel the weight of an object in our hands and know its mass. This grounding is necessary for life on Earth, but it acts as a mental barrier when we attempt to look beyond our atmosphere. Consider the humble meter or yard. These units are literally based on the human body, the length of a stride or the reach of an arm. When we use these units to measure a house or a street, they make perfect sense. Even when we scale up to the size of our planet, we can still, with effort, visualize it. We can imagine a flight across the ocean taking 12 hours, and our brains can loosely stitch together that duration with the physical distance covered. We can look at a globe and understand that the thin blue line of the atmosphere is fragile, but even at this stage, the anchor begins to drag. The Earth is roughly 12,742 kilometers in diameter. If you were to try to walk that distance without stopping, it would take you months of continuous movement. Already, the human scale is beginning to fray at the edges. The problem is that the universe does not operate on a human scale. It operates on a cosmic one. As soon as we leave the surface of our world, the numbers don't just get larger, they change in quality. They become abstract. When we say the moon is 384,400 kilometers away, the brain hears the number, but it cannot feel the distance. It loses the tactile connection it has with a kilometer-long walk. This is the lunar gap, the first true test of our ability to let go of our terrestrial anchors. To bridge this gap, we often use analogies, telling ourselves that you could fit 30 Earths in the space between us and the Moon. We use these mental crutches because the raw data is too vast for our ancestral hardware to process. We are trying to run cosmic-scale software on hunter-gatherer hardware. This limitation isn't just a quirk of psychology, it's a fundamental challenge in how we communicate the story of space. If we cannot relate to the distance of our nearest neighbor, how can we hope to grasp the distance to the Sun? The Sun is 150 million kilometers away. At this point, the kilometer has become a redundant tool. Using it to measure the solar system is like trying to measure the width of the Atlantic Ocean using the thickness of a human hair. It is technically possible, but the resulting number is so large that it ceases to mean anything to the human mind. This is why we must transition into new units of thought. We have to learn to think in terms of light-time understanding that even at the fastest speed allowed by the universe, it still takes 8 minutes for a photon to travel from the Sun to your eyes. By anchoring ourselves in the human experience first, we acknowledge our starting point. We admit that we are small, that our perspective is local, and that our intuition is often wrong when applied to the stars. This humility is the prerequisite for discovery. We must accept that our senses were never designed to perceive the curvature of space-time or the billion-year life cycles of stars. We are effectively scale blind. Just as a person born without the ability to see color must rely on instruments to tell them the sky is blue, we must rely on mathematics and technology to tell us the true dimensions of the void. The human anchor is also about time. We live for perhaps 80 or 90 years. To us, a decade is a significant portion of our existence. A century is ancient history. But in the cosmic script, a million years is a blink. The stars we see at night are not static. They are in violent, constant motion. But because their lives span billions of years, they appear frozen to our short-lived eyes. Our anchor in time is just as restrictive as our anchor in space. We view the universe as a still photograph, when in reality it is a chaotic, high-speed film. To understand space-themed stories, we have to mentally speed up our perception of time while slowing down our expectation of distance. Every story we tell about the stars is an attempt to pull the cosmos down to our level. When we talk about interstellar travelers or galactic empires, we are using human political and social structures to make the infinite feel intimate. We give names to constellations, warriors, queens, and animals to turn a terrifyingly vast vacuum into a familiar neighborhood. This is a necessary survival mechanism. Without the human anchor, the sheer scale of the universe would be paralyzing. It would be a total perspective vortex that could crush the human spirit under the weight of its own insignificance. But there is a beauty in this struggle. The fact that a creature whose world is measured in footsteps can calculate the mass of a black hole or the age of a distant galaxy is a testament to the power of the mind to transcend its biological limits. We are anchored to the Earth by gravity and to our history by evolution, but our curiosity is unanchored. We use the familiar, the walk, the mile, the minute as a springboard to leap into the unfamiliar. We build mental ladders, starting with the human scale and slowly adding rungs of increasing magnitude until we can reach the stars. As we move forward into the deeper segments of the cosmic story, keep this anchor in mind. It is your point of reference. Every time we speak of a distance that breaks the brain, remember that it only breaks the brain because the brain was built for the forest and the field, not the vacuum. By recognizing the boundaries of our internal map, we can finally begin to explore the territory that lies beyond the edges. We are the bridge between the microscopic and the macroscopic. We are the observers who give the scale a name. In the following segments, we will leave the shore of the familiar. We will watch the Earth shrink until it is nothing more than a pale blue dot, and then we will watch that dot vanish entirely. We will see structures so large that they defy the cosmological principle, and we will encounter anomalies that suggest our current maps are incomplete. But no matter how far we travel, we always carry the human anchor with us. It is the "you are here" marker on the map of the infinite. It is what allows us to say, "I am small, but I am here, and I am looking." This realization that we are tiny observers in a vast theater is not a reason for despair, but a reason for wonder. The human anchor teaches us that scale is relative. To an ant, a backyard is a continent. To us, the Earth is a world. To the universe, we are a momentary flicker. But within that flicker, we have found the courage to look up and ask, how big is it all? And more importantly, where do we fit in? The journey starts here, with a single step, a 10-minute walk, and the realization that the horizon is much, much further than it looks. This realization that we are tiny observers in a vast theater is not a reason for despair, but a reason for wonder. The human anchor teaches us that scale is relative. To an ant, a backyard is a continent. To us, the Earth is a world. To the universe, we are a momentary flicker. But within that flicker, we have found the courage to look up and ask, how big is it all? And, more importantly, where do we fit in? The journey starts here, with a single step, a 10-minute walk, and the realization that the horizon is much, much further than it looks. To begin this expansion of our perspective, we must look at the tools we use to hold on to our reality. Think about your home. The average house is a space you can walk across in 30 seconds. You know the texture of the walls, the creak of the floorboards, and the exact distance from the front door to the kitchen. This is your primary anchor. It is a scale that makes perfect sense to your brain because you experience it every second of every day. Your brain evolved to understand these immediate, tactile spaces, areas you can see, touch, and navigate without a second thought. But when we move from the living room to the city, the anchor begins to slip. We start relying on technology, like cars and maps, to bridge the gap between what we can see and where we need to go. We are already abstracting our reality. The problem is that the leap from a city to a planet is nothing compared to the leap from a planet to the void. Imagine standing on a football field. It's about 360 feet long, a distance you could stroll across in 2 minutes. Now, imagine laying 17 of those fields end to end. That is a mile. Comet. A mile is a distance most of us can still visualize. It's a 20-minute walk, a common measurement for a morning jog. But to reach the edge of our own atmosphere, you would need to stack 62 miles of those football fields vertically. This is the Kármán line, the invisible boundary where the sky turns to space. Even at this relatively short distance, our human intuition fails. We cannot see 62 miles up. We only see a blue haze that fades into black. This brings us to the lunar gap. The moon is our closest neighbor, sitting approximately 238,855 miles away. To a human brain, that number is just a digit on a page. To bring it back to the anchor, consider this. If you could drive a car at highway speeds toward the moon, it would take you nearly 6 months of non-stop driving to get there. No red lights, no gas stations, just 160 days of driving through a vacuum. If you chose to walk, it would take you 9 years. This is the first rung on the cosmic ladder where the human scale starts to feel absurd. We use these analogies like fitting 30 Earths between us and the moon, not because they are scientifically precise, but because they are the only way to prevent our minds from shutting down in the face of such emptiness. Once we pass the moon, the anchor is no longer dragging, it is severed. The distance to the sun is 93 million miles. This is the solar anchor, the unit we call an astronomical unit, AU. If the moon was a 9-year walk, the sun is a walk that would take you 3,500 years. You would need 40 generations of your descendants to keep walking just to reach the light. This is why we stop using miles and start using light time. Light is the fastest thing in the universe, traveling at 186,000 miles per second. It can circle the Earth 7 times in a single heartbeat. Yet, even at this impossible speed, it takes light 8 minutes and 20 seconds to reach us from the Sunday. When you look at a sunset, you are seeing the sun where it was nearly 9 minutes ago. You are already looking into the past. This temporal shift is a crucial part of the human anchor. We are used to things happening now. If you drop a glass, it breaks now. If you call a friend, they hear you now. But in space, now is a localized concept. The further out we look, the further back in time we see. This creates a strange paradox. The larger the universe gets, the older the information we receive becomes. By the time we look at the nearest star system, Proxima Centauri, we are looking 4 years into the past. If that star were to vanish today, we wouldn't know for another 4 years. We are anchored in a present that doesn't exist for the rest of the cosmos. To understand the scale of a galaxy like our Milky Way, we have to stretch the anchor until it breaks. Our galaxy is 100,000 light-years across. If you were to scale the entire Earth down to the size of a single grain of sand, the Milky Way would still be the size of the entire United States. Think about that for a moment. Every mountain, every ocean, every city, and every person who has ever lived, all shrunk into one speck of sand, and the neighborhood it lives in is still a continent wide. This is the true scale that makes Earth disappear. We aren't just small, we are mathematically insignificant in terms of volume. And yet the Milky Way is just a mid-sized galaxy. When we look at giants like IC 1101, which is 6 million light-years across, the Milky Way itself becomes the grain of sand. IC 1101 is so large it could swallow thousands of Milky Ways. It is a cosmic monster, a graveyard of galaxies that have been consumed over billions of years. At this scale, The human anchor is so far behind us that it's almost impossible to find. We are talking about structures that take millions of years just for a single particle of light to cross. If you were on one side of IC 1101 and sent a hello message to the other side, by the time it arrived, your entire species might have evolved into something else or vanished entirely. But why does this matter to us, the observers? It matters because it defines the cosmological principle, the idea that on a large enough scale, the universe looks the same everywhere. But our recent discoveries of defiant anomalies suggest this might not be true. We have found structures like the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure is so large it shouldn't exist according to our current models of how the universe grew. It is a knot in the fabric of space that defies the smoothness we expected. These are the things that keep astronomers awake. They are the moments where our mathematical anchors fail, and we realize that the universe is even stranger than we imagined. We also encounter interstellar visitors like 3I, Atlas, or Oumuamua objects that don't belong to our sun. They come from the dark, silent reaches between stars, carrying secrets of other worlds. When we see these objects, the human anchor feels a different kind of tug. It's not just about size, it's about loneliness. We look at these drifting rocks and wonder if they were once part of a system like ours, or if they are the cold spots of a distant, dying sun. They remind us that our solar system is not a walled garden, but a porch light in a very dark forest. The human anchor is also a shield against the vast empty. Between the galaxies lie the voids, spaces, millions of light years across where there is almost nothing. No stars, no planets, just a few stray atoms per cubic meter. If you were placed in the center of the Boötes void, you wouldn't see a single star in the night sky. It would be total, absolute darkness in every direction. For a creature evolved to follow the sun and the moon, this kind of emptiness is a sensory nightmare. Our anchor helps us populate that darkness with meaning. We look at the Great Attractor, a mysterious gravitational anomaly pulling our entire region of space toward it, and we give it a name. We turn a terrifying physical force into a character in our cosmic story. Consider the smallness of our achievements. We have sent probes like Voyager 1 into the interstellar medium. It has been traveling for nearly 50 years at 38,000 miles per hour. In human terms, that is incredibly fast. In cosmic terms, it hasn't even left the front yard. It will take Voyager 40,000 years to reach the vicinity of another star. This is the reality of the distance that breaks our brains. We are a species that lives for decades, trying to conquer a universe that operates in eons. However, there is a flip side to this insignificance. If the universe is so large and we are so small, then the fact that we can understand it at all is a small miracle. We are an arrangement of atoms, carbon, nitrogen, oxygen forged in the hearts of dying stars. We are literally stardust that has come together in such a complex way that it can now turn around and study the stars that made it. The universe is looking at itself through our eyes. When we calculate the distance to a quasar or the mass of a supermassive black hole, we are the universe's way of knowing itself. The human anchor isn't just a limitation, it's a perspective. Without the anchor, size has no meaning. A galaxy is only big because we know what small feels like. The vacuum is only empty because we know what a crowded city street feels like. We provide the contrast. We are the yardstick by which the infinite is measured. Every space-themed story, whether it's about a journey to Mars or the collision of two galaxy clusters, is ultimately a story about us. It's about how our human hearts react to the cold, beautiful indifference of the stars. As we continue to explore, we must be prepared for our anchors to be tested again and again. We will find impossible stars that are older than the universe itself. We will hear strange signals from the deep that might be natural or might be something else. We will see giant circles in the sky that hint at events from before the Big Bang. Each time, we will try to drag our human-scale units, our kilometers and our miles out into the deep to make sense of it. And each time, they will fail us, forcing us to grow, to adapt, and to build a bigger anchor. The human anchor is our starting point, but it is not our destination. It is the solid ground we stand on before we take the leap. We must respect our limitations, but we must never be imprisoned by them. We are the bridge builders. We bridge the gap between the grain of sand and the galaxy. We bridge the gap between the 10-minute walk and the billion-year journey. So, as we move into the next segments of this general script, as we look at the true scale, the light years, and the anomalies, remember the anchor. Remember the smell of rain on pavement, the warmth of the sun on your skin, and the simple reality of a 1-mile walk. Hold those things close. They are what make the vastness of space worth exploring. They are the reason we look up in the first place. We don't go into the dark to get lost. We go into the dark to find out just how bright our own small light truly is. We have grounded ourselves. We have acknowledged our size. Now, we are ready to leave the shore. The horizon is calling, and though it is further than it looks, we have everything we need to begin the crossing. The universe is vast, but it is also ours to observe. And that, in the end, is the most human anchor of all. This delay is the first layer of the deep drift. It is a reminder that the universe has a built-in latency. We are always looking at the past. The further we look, the deeper into history we descend. This challenges how we think about the present moment. Is there even such a thing as now for the entire universe? Plus, or is now just a local experience, limited by the speed at which information can travel? Scientists have spent centuries debating this, and yet the mystery remains as calm and quiet as the stars themselves. Consider the Voyager spacecraft, the furthest human-made object. It has been traveling for decades, moving faster than any bullet ever fired. Yet, if we were to send a light signal to Voyager today, it would reach the craft in less than a day. Light covers in hours what it takes our best technology half a century to achieve. This is the scale of the marathon light is running. It is a constant, tireless sprint across a stadium that has no walls. But even with everything we've learned, there are still things we don't fully understand. We don't know why light moves at this specific speed. Why 300,000 kilometers per second? Why not more? Why not less? It is one of the fundamental constants of nature, a number woven into the fabric of space-time itself. It doesn't need to be explained or justified. It simply is. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. As we settle into this scale, let your mind rest on the idea of the light second. It is a distance of 300,000 kilometers, nearly 10 times the circumference of the Earth. It is a massive distance, yet it is only 1/62nd of a light minute, and a light minute is but a tiny fraction of a light year. We are building a tower of scale, and the light second is just the foundation. Imagine you are a traveler made of light. You leave the Earth behind. In 1 second, you have passed the moon. In 2 minutes, you are passing the inner planets. In 8 minutes, you reach the Sunday. 12. You are moving so fast that the planets appear like stationary marbles in a vast, dark room. But as you look ahead, you realize the room is much larger than you thought. The next nearest object is not minutes away. It is not hours away. It is years away. This is where the true scale of the light year begins to reveal itself. To cover the distance of 1 light year, you would have to maintain this 300,000 kilometer per second pace for 31,536,000 seconds. Every second, another 300,000 kilometers. Every hour, another billion kilometers. Day after day, month after month, for an entire year. By the end of that journey, you would have traveled nearly 9.5 trillion kilometers. That is 1 light year. If we tried to use kilometers to describe the distance to the nearest star, we would be talking about 40 trillion kilometers. The numbers become a noise, a static that our brains cannot process. But 4.2 light years is something we can hold. It is a duration. It is the length of a high school education. It is the time it takes for a toddler to become a student. It gives the distance a human heartbeat. As you drift closer to sleep, imagine these beams of light crossing the void. They are silent. They do not carry heat across the vacuum. They are just pure information, pure energy, traveling through a cold, dark expanse that is mostly empty. The universe is not a crowded place. It is a series of very small lights, separated by very large silences. The light year is the measurement of that silence. We are moving outward now, leaving the realm of the light second and the light minute. We are entering the space where the light year becomes the only sensible way to speak. It is a transition that feels inevitable, like the slow turning of the tide. You don't need to do anything. You don't need to solve any equations. Just let the speed of light become the background rhythm of your thoughts. The universe moves slowly over immense spans of time, even when it is moving at the speed of light. And for now, that uncertainty, that vastness, is simply part of the picture. It is a safe place to be. You are here, in your bed, while the light is out there, doing the work of bridging the distances for you. With that in mind, let's move outward once more, to an even larger scale, beyond the speed of light, beyond the inner solar system, and toward the gaps that define our place in the galaxy. We are now entering the territory where the human scale anchor no longer just slips, it vanishes entirely. To understand the transition from the speed of light to the distance of a light year, we have to look at the sheer, overwhelming volume of the vacuum. Imagine for a moment that we could drain the universe of all its stars, all its planets, and all its dust. What remains is the canvas upon which light performs its marathon. This canvas is so vast that even at 300,000 kilometers per second, light is not a flash. It is a slow, steady pulse, a lonely traveler crossing a desert that has no markers. As we drift further from the sun, we begin to encounter the true nothingness that defines the cosmos. In our daily lives, empty usually means a room without furniture or a glass without water. But in the space between the stars, empty is a profound, almost mathematical purity. There are regions of space where you could travel for a light year, 9.5 trillion kilometers, and encounter fewer atoms than you would find in a single grain of sand. This is the low-density reality that light must navigate. When we say that a star is 4 light-years away, we aren't just saying it's far. We are saying there is a 4-year-long gap of absolute, freezing silence between us and that distant fire. Scientists understand this by calculating the look-back time. This is a concept that acts as a verbal dissolve between the present and the past. Because light has a fixed speed, every distance in the universe is also a measurement of history. If you look at an object that is 1 light year away, you are seeing it exactly as it appeared 365 days ago. You are not looking across space so much as you are looking through time. This challenges how we think about the reality of the now. In the deep drift of the galaxy, there is no simultaneous moment. Each star exists in its own bubble of time, sending out messages that will not be received for years, decades, or centuries. Consider the sheer scale of a single light year once more. To visualize 9.5 trillion kilometers, imagine the distance from the Earth to the Sun, that 8-minute journey we discussed earlier. Now, take that distance and stack it end to end 63,000 times. That is 1 light year. It is a distance so long that if you were to represent the Earth-Sun distance as 1 inch, a single light year would still be over a mile long. And remember, the nearest star is over 4 of those miles away. This is the scale expansion that begins to blow the human mind. We aren't just moving away from home, we are moving into a geography that refuses to be tamed by our standard maps. What makes this strange is not what we see, but what we don't understand about the nature of the vacuum itself. Astronomers didn't expect to find that space is expanding, a discovery that adds a layer of quiet complexity to our journey. As light travels its 9.5 trillion kilometers every year, the space it is traveling through is itself stretching, very slightly, every second. It's as if the marathon track is growing longer while the runner is mid-stride. This doesn't affect our local neighborhood much, but over the immense periods of time that light spends in transit, it changes the very color and energy of the light itself. It is a slow, rhythmic stretching of reality that happens without hurry and without end. As you listen, let the rhythm of these numbers settle into your breathing. Ow, 300,000 kilometers per second. 18 million kilometers per minute. 1 billion kilometers per hour. These are not numbers to be feared or solved. They are simply the heartbeat of the vacuum. They represent the tireless work of the universe, moving energy from one place to another across the dark. You are safe in the knowledge that this process is constant. The speed of light does not falter. It does not tire. It is the one thing in the universe that remains exactly the same, no matter where you are or how fast you are moving. And for now, that uncertainty about why the universe is so large and why we are separated by such vast gulfs of time is simply part of the picture. It doesn't need to be resolved tonight. We can accept the silence of the light years. We can accept that the stars we see tonight are ghosts of their past selves, and that our own light is currently traveling outward, a faint signal crossing the void to reach eyes that won't exist for another million years. This is the cosmic continuity, the realization that we are all part of a single, slow-moving story. Imagine you are a photon that has just finished its first year of travel. You have covered 1 light year. You look back, and the sun is no longer a blinding disk. It has shrunk to a bright, steady point of light, one star among many. You look forward, and the destination still looks impossibly far away. There is no wind in space, no sound, and no resistance. You are simply falling through the dark at the maximum possible speed, a tiny spark of information in a cathedral of shadow. This is the essence of the scale loop. We expand our view, we realize the vastness, we accept the mystery, and then we move outward once more. To understand that, we need to step back and look at the human scale perspective one last time before it disappears completely. On Earth, we think of a year as a long time. It is a cycle of seasons, a series of memories. But to the universe, a year is just the time it takes for light to cross a tiny fraction of a galaxy. When we combine the two, the human year and the cosmic speed, we get the light year. It is our way of speaking the universe's language using our own alphabet. It is a gentle humility, acknowledging that while we may be small, we have found a way to measure the infinite. As we conclude this first scale loop, let the image of the light marathon carry you toward a deeper state of relaxation. The light is moving, but you are still. The universe is vast, but you are warm and safe. The distances are mind-blowing, but they are also orderly and predictable. There is a peace in the precision of the speed of light. It is the ultimate clock, ticking away the seconds across the trillions of kilometers. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. We have reached the first marker on our journey. We have looked at the speed, we have looked at the distance, and we have accepted the delay. We are now ready to leave the inner solar system behind for good and look at the objects that wait for us in the deep, quiet dark of the interstellar gaps. With that in mind, let's move outward once more, to an even larger scale. Now, let's slowly expand outward. One level beyond the speed of light lies our own neighborhood, the solar system. To truly grasp the weight of a light year, we must first look at the smaller, more intimate delays that happen right here in our own backyard. We often think of our solar system as a single cohesive unit, a family of planets huddling around a central fire. But even within this family, the distances are so great that light, the fastest messenger in existence, begins to show the first signs of its struggle against the void. This is where we first encounter the lag of reality, a gentle reminder that nothing in the universe happens in a true, synchronized now. What we know so far suggests that the moon is about 384,000 kilometers away. To our human scale perspective, this is a massive distance, a journey that took the Apollo astronauts 3 days of intense travel to complete. But for light, this gap is merely a brief pause. When you look up at the moon tonight, you are seeing it as it was 1.3 seconds ago. It takes that long for the sunlight bouncing off the lunar surface to reach your eyes. This is the lunar delay. It is a small, almost imperceptible gap, but it is the first crack in the illusion of an instantaneous universe. If a large boulder were to roll across the lunar plains, or if a meteorite were to strike the surface, you would remain unaware of it for over a second. You are always watching, a slightly delayed broadcast of our nearest neighbor. As we move past the moon, the seconds begin to turn into minutes. The sun, the very engine of our lives, sits much further away, about 150 million kilometers. This is the distance astronomers call an astronomical unit, or 1 AU. It is the gold standard for measuring our local neighborhood. Yet, even light needs time to cross this threshold. It takes 8 minutes and 20 seconds for a photon to travel from the surface of the sun to the Earth. If the sun were to suddenly go out, we wouldn't know it for 8 minutes. We would continue to live in its warmth and light, unaware that its source was already gone. Children would keep playing in the park, solar panels would continue to generate power, and the world would remain bright, all while the sun itself was already dark. We would continue to orbit a ghost of a star for those final 8 minutes. This comparison isn't perfect, but it gives us a calm place to begin. It shows us that even the most fundamental things in our lives, the very light of day, are subject to the patient laws of cosmic distance. Scientists understand these delays by observing the movement of the planets. When we send rovers to Mars, for instance, we cannot drive them in real time with a joystick. Depending on where Mars and Earth are in their orbits, the light delay can be anywhere from 3 to 22 minutes. If a rover is heading toward a cliff, the signal telling it to stop takes minutes to arrive, and the confirmation that it has stopped takes another few minutes to return. We are forced to communicate with the solar system through a veil of time. We are always talking to the past version of the planets, and they are always responding to a past version of us. But even with everything we've learned, there are still things we don't fully understand about how these distances affect our perception. Not because we're missing something urgent, but because the universe moves slowly over immense spans of time. To understand the scale, imagine you are standing in a vast, dark forest. You have a friend standing a few hundred yards away with a bell. When they ring the bell, you hear the sound a moment later because sound travels slowly. In the solar system, light is like that bell. It is incredibly fast, but the forest is so big that the sound of the light still takes time to reach your ears. As we drift further out to the gas giants like Jupiter and Saturn, the minutes turn into hours. When we look at Jupiter, we are seeing it as it was 40 minutes ago. When we look at Saturn, the light has been traveling for over an hour. If you were to watch the beautiful rings of Saturn through a telescope, you are seeing them not as they are in this moment, but as they were while you were perhaps finishing your dinner or starting this very script. The universe is a series of nested time capsules, each one holding a slightly older version of reality. This brings us to a quiet realization. We are never truly in the present when we look at the sky. We are observers of history. The light minutes that separate us from the planets are the first steps toward the light years that separate us from the stars. It is a gradual expansion of the now until it becomes so thin that it disappears entirely. In our daily lives, we measure time in seconds, minutes, and hours. But in the solar system, we begin to see that time and distance are the same thing. 1 AU is not just 150 million kilometers, it is also 8 light minutes. The distance is the time. Astronomers didn't expect the solar system to feel so empty, yet the gaps between the planets are far larger than the planets themselves. If you were to shrink the sun to the size of a grapefruit, the Earth would be a tiny grain of sand about 50 feet away. Jupiter would be a cherry about 2 blocks away. And the nearest star, that grapefruit, would be thousands of miles away. This is why we need the light year. Kilometers are too small to bridge the gaps between the fruits in our cosmic orchard. When we think about distance, we often imagine it in human terms. Distances we can walk, time we can measure in years, objects we can see with our own eyes. Our brains are beautifully adapted for the world we inhabit, a world of rolling hills, city blocks, and horizons that seem far away but are actually quite intimate. When you plan a trip to see a friend in another town, you think of it in hours spent in a car. When you go for a morning stroll, you think of it in the rhythm of your footsteps and the gentle passage of minutes. This is our anchor. It is a safe, predictable way of measuring the reality around us. For example, consider the simple act of walking. A kilometer is a distance most of us can visualize clearly. It is roughly 10 to 12 minutes of steady movement. If you were to set out on a walk today and continue until the sunset, you might cover 30 or 40 kilometers. You would feel that distance in your muscles. You would see the landscape change slowly from one neighborhood to the next. This is a scale that makes sense. It is tangible. If you were to walk across an entire continent, it would take you months of dedicated effort, a journey that would define a significant portion of your year. But as we begin to look upward, these human measurements start to feel a bit like trying to measure the depth of the ocean with a teaspoon. To understand a light year, we first have to realize just how much room there is in our own immediate surroundings. Let's look at our own world, the Earth. It is approximately 12,700 kilometers in diameter. To us, that is massive. It contains every ocean, every mountain range, and every city ever built. If you were to get into a commercial airplane and fly non-stop around the equator, it would take you about 2 full days of constant travel. That feels like a long time. It is a distance that commands respect in our minds. Yet, compared to the distances we are about to discuss, the Earth is effectively a single point. Even the gap between us and our closest neighbor, the Moon, begins to strain our human-scale perspective. The Moon is about 384,000 kilometers away. That is roughly 30 Earths laid side by side. If you could somehow drive a car to the Moon at highway speeds, it would take you about 6 months of driving 24 hours a day without a single stop for gas or rest. 6 months. That is half a year of your life spent just crossing the empty space between us and the nearest object in the sky. This comparison isn't perfect, but it gives us a calm place to begin. It reminds us that even near things in space are incredibly far by human standards. And yet, light crosses that same 384,000 kilometer gap in just over 1 second. 1 second. In the time it takes you to draw a single breath, a beam of light has already completed the journey that would take you half a year to drive. This is the first hint of the staggering efficiency of light, and the first clue as to why we need a new way to measure the universe. As we sit here, grounded and safe, we can begin to appreciate the stillness of our own scale. We live in the realm of centimeters, meters, and kilometers. We live in the world of the now, where we assume that when we see something, it is happening exactly as we perceive it. If a friend waves at you from across the street, you see them instantly. There is no lag, no delay that our senses can detect. But as we step further out, we will find that the universe has a speed limit. and that limit creates a bridge between distance and time. Imagine for a moment a vast, empty field. If you stand on one side and a friend stands on the other, and you both hold powerful flashlights, the light from their lamp seems to hit your eyes the exact moment they click the switch. On this scale, light is effectively infinite. It moves so fast, 300,000 kilometers per second, that it feels like a magical, instantaneous presence. Our ancestors, looking up at the stars, likely felt the same way. To them, the stars were just lights on a dome, distant but present, shining their light upon the earth without any sense of travel time. But the reality is more patient. The universe is more deliberate. To understand the light year, we must accept that every piece of light we see is a traveler that has survived a long, lonely journey. Even the light from the sun, which warms your skin on a summer afternoon, is a traveler. The sun is 150 million kilometers away. That is a distance so large that the highway driving analogy breaks down. It would take you 150 years to drive there. You would be born, live your entire life, and pass away behind the wheel before you even made it halfway. And yet, for light, this journey takes only 8 minutes and 20 seconds. When you look at the sun safely, through a filter or at sunset, you are not seeing it as it is now. You are seeing it as it was 8 minutes ago. If the sun were to vanish this very instant, we would continue to feel its warmth and see its light for nearly 9 minutes, blissfully unaware of the change. We are always living in the recent past of the stars. This realization is our first step toward letting go of our human scale perspective. We are moving from a world where everything is here and now to a universe where here is separated by vast thens. It is a shift from the concrete to the expansive. But do not let this make you feel small in a way that is cold or frightening. Instead, see it as a form of cosmic grace. The universe is so large that it allows us to see into the past simply by looking up. It provides us with a history book written in photons. As we prepare to leave the human scale behind and enter the first of our scale loops, take a moment to appreciate the sturdiness of your surroundings, your chair, the walls, the gentle rhythm of your breathing. These are your anchors. They are the zero on our cosmic ruler. From this safe, quiet vantage point, we are going to slowly extend that ruler, 1 light second, 1 light minute, and eventually 1 light year at a time. There is no rush to get there. The stars have been waiting for billions of years. They can wait a few more hours for us to arrive. For now, just hold on to the image of that single beam of light, leaving the sun, traveling through the cold dark for 8 minutes, and finally reaching the earth to illuminate a single leaf or a single window. It is a long way to go for such a small thing, but the universe is full of such journeys. With that in mind, let's move outward once more, to an even larger scale. We are leaving the comfort of the minutes and hours we know, and entering the realm where light begins its true marathon. To understand why we must abandon the kilometer and the mile, we have to look at the sheer inadequacy of our everyday numbers when applied to the celestial void. If we were to stay within our human scale perspective, the numbers would soon become so long that they would lose all meaning, becoming a mere blur of zeros that the mind instinctively ignores. This is why the light year exists, not just as a unit of measurement, but as a bridge for our imagination. Consider, for a moment, the distance across our own planet once more. If you were to take a standard ruler and try to measure the distance from New York to Tokyo, you could technically do it. The number would be in the millions of centimeters, perhaps, but it would be a number you could still write down on a piece of paper. But as soon as we point that ruler toward the sky, the scale shifts in a way that is almost humorous in its disproportion. Our world, with all its vast oceans and towering peaks, is effectively a grain of sand in a desert that has no end in sight. When we speak of human-scale perspective, we are also speaking of human-scale time. We measure our lives in decades. We measure our history in centuries. To us, 1,000 years is an unimaginably long time, 10 times the length of a long human life. It is the span of empires. Yet, in the context of the distances light must travel, 1,000 years is barely a heartbeat. To understand the light year, we have to marry these two concepts, the distance light covers and the time it takes to do it. It is a measurement that forces us to realize that looking out is the same as looking back. If you were to stand on a hill and look at a mountain range 50 kilometers away, you are seeing those mountains as they were a tiny fraction of a second ago. The delay is so small, roughly 0.00016 seconds, that your brain treats it as instantaneous. This is the comfort of the human scale. Everything we see is now, but as we move outward, this now begins to stretch and tear. By the time we reach the edge of our solar system, the now has become hours. By the time we reach the nearest stars, the now has become years. This is the human scale anchor slipping away, allowing us to drift into the deep drift phase of cosmic understanding. Imagine you are standing in a perfectly dark, quiet room. In the center of the room is a single candle. The light from that candle reaches the walls almost immediately. Now, imagine that room expanding. The walls move back miles, hundreds of miles, millions of miles. The candle remains in the center, a tiny, flickering point of light. If you are standing at the far wall, you have to wait. You have to wait for those tiny particles of light to cross the dark. This wait is the essence of the light year. It is the patience of the universe. In our daily lives, we are used to things being fast or slow. A car is fast compared to a walker. A plane is fast compared to a car. But light is the ultimate speed. It is the speed limit of reality. Nothing can go faster. And yet, even at this ultimate, impossible speed, the universe is so vast that light appears to crawl. To a photon, the trip from one side of a galaxy to another is a marathon that lasts longer than the entire history of the human species. When we use the term light year, we are acknowledging this paradox, that the fastest thing we know is still far too slow to make the universe feel small. Scientists understand this scale because they have to. Without the light year, the maps of the stars would be cluttered with numbers so vast they would be impossible to use in calculations. Imagine trying to describe the distance to a galaxy in inches. The number would have more digits than there are stars in the sky. The light year is our way of simplifying the infinite. It is a human-scale word applied to a non-human reality. It is a way for a creature that lives for 80 years to talk about a universe that has existed for 13 billion. As we settle deeper into this exploration, let the familiar world fade. The roads, the clocks, the schedules of tomorrow, they all belong to the scale of meters and minutes. Here, in the quiet expanse of the script, we are moving into the scale of the light year. This is a place where a short distance is trillions of kilometers. A place where recently means a few centuries ago. It is a safe place to be, because in this vastness, the small pressures of our lives find their proper perspective. They are not erased, but they are framed by a silence that has lasted for eons. Think of the light year as a long, steady breath. It is the distance light travels while the Earth makes one full trip around the Sunday. While you experienced 4 seasons, while you celebrated a birthday, while the trees grew and the snow fell, a beam of light was moving through the void, never stopping, never slowing, covering 9.5 trillion kilometers. It did this while you slept, while you worked, and while you dreamed. Every year of your life, light has added another light year of distance to its journey. This is the perspective we will carry with us as we move into our first scale loops. We will start with the small delays, the seconds and minutes, and gradually build our way up to the years, the centuries, and the millennia. We are not just traveling through space, we are traveling through time. And we are doing it together, safely anchored by the sound of this narrative. There is no need to hurry. The distance is already there, waiting for us to acknowledge it. The human scale perspective is our starting point, our home base. It is the familiar that we will return to at the very end. But for now, we are going to let the anchor lift. We are going to let the shore of the familiar world recede until it is just a tiny, pale blue dot in the rearview mirror of our imagination. We are moving into the realm of the light year, where the distance truly begins to blow our human minds, not with noise or chaos, but with a quiet, breathtaking vastness. And for now, that uncertainty of how we fit into such a large map is simply part of the picture. It doesn't need to be resolved tonight. We are simply moving outward, step by step, light second by light second, into the beautiful dark ocean of the cosmos. Now, let's slowly expand outward. One level beyond what we just explored lies the speed of light itself. To grasp the distance of a light year, we must first become intimately acquainted with the traveler that defines it. Scientists understand a light year by observing the fastest thing in the universe. Light travels at about 300,000 kilometers every single second. This is a speed that defies our biological wiring. In the time it takes you to blink a mere fraction of a second, a beam of light has already circled the Earth 7.5 times. It is a speed that seems instantaneous to our human senses, yet in the grand architecture of the cosmos, it is the fundamental yardstick by which all things are measured. When you flip a switch in your home, the room is filled with light immediately. There is no perceived delay between the movement of your hand and the illumination of the walls. For all intents and purposes in our daily lives, light is omnipresent. But as we step away from our atmosphere and into the vacuum, we realize that light is not a state of being. It is a physical entity moving through space. It has a beginning, a middle, and an end to its journey. It is a constant, unwavering pulse that dictates the very rhythm of reality. To visualize this speed, imagine you are standing at the start of a long, straight track that stretches into the horizon. If you were to fire a laser beam down that track, by the time you could even begin to process the flash of the light, that beam would be thousands of kilometers away. If we compare this to our human scale anchor, the disparity is almost humorous. A commercial jet travels at about 900 kilometers per hour. A beam of light travels at over 1 billion kilometers per hour. If you were to race the two, the jet would appear to be standing perfectly still, frozen in time, while the light vanished into the distance. What makes this strange is not just the speed, but the fact that this is the absolute limit. Astronomers didn't expect to find a universe with a hard speed cap, but nature has provided one. No matter how much energy you use, no matter how powerful your engine, you can never overtake a beam of light. It is the gold standard of the universe. And yet, even at this impossible velocity, the universe is so vast that light often appears to crawl. This is the central paradox of cosmology. The fastest thing we know is still far too slow to make the universe feel small. Imagine a single photon, a tiny packet of energy, leaving the surface of a star. It has no mass, no weight, and it experiences no time. From the photon's perspective, its journey from the center of the galaxy to your eye is instantaneous. But for us, standing on this small blue planet, we must wait. We must wait for years, centuries, or even millennia for that photon to complete its trek across the void. This waiting is what defines our perspective. It is why we cannot talk about distance in space without also talking about time. A light year is the marriage of the two, the distance covered in the time it takes the Earth to orbit the Sun once. As you listen to these words, think about the light in the room again. It feels now, but it is actually a few nanoseconds old. When you look at the person sitting across from you, you are seeing them as they were a billionth of a second ago. On Earth, this doesn't matter, but as we move outward, the lag becomes meaningful. If you were to stand on the moon and shine a laser back at Earth, it would take 1.3 seconds to arrive. If you were having a conversation with someone on the moon, there would be a gentle, rhythmic pause between every sentence, a 1.3-second gap that you could never bridge. And so the universe continues, expanding, cooling, changing, slowly, quietly, endlessly. You don't need to stay awake for this part. The comet is moving now, even as you breathe, drifting through the orbit of the outer giants. The universe will still be here, moving gently forward, long after this moment passes. The stars will continue to shine their cold light on the icy surface of the nucleus. The gravity of the sun will continue its invisible tug. The vastness will remain vast. And somewhere within all of this, we can begin again by starting with something familiar. As the echoes of the day begin to fade into the background of your consciousness, the true scale of the night reveals itself. It is a soft, welcoming dark, the same dark that has cradled Comet Bernardinelli Bernstein for 4 billion years. The expansion of the universe is not a violent event, but a slow, graceful stretching of the fabric of reality. It is a thinning of the veil, a gentle widening of the space between the stars. In this widening, there is room for everything to find its rest. The comet does not fight the expansion, it does not resist the cooling, it accepts the slow loss of heat as a return to its natural state. You too can accept the cooling of your thoughts. You can allow the warmth of the day's activities to radiate away, leaving behind a clear, quiet space. The movement of the comet through the orbit of the outer giants is a silent procession. Right now, in the time it takes for you to take a single, deep breath, the 85-mile-wide mountain of ice has moved only a tiny fraction of its journey. It is passing through the gravitational influence of worlds we only know as points of light: Neptune, Uranus, the cold sentinels of the outer dark. These planets are massive, yet they do not disturb the comet's peace. They are simply fellow travelers in a very large room. The universe will still be here, performing these slow, geometric dances, whether we observe them or not. There is a profound comfort in the idea of the universe moving gently forward. It does not lurch, it does not jump, it glides with the momentum of billions of years. 10, 10, 10. The cold light of the stars is a constant. On the surface of the comet, that light doesn't feel like a spotlight. It feels like a soft, silver dust. It illuminates the jagged edges of the ancient ice, the deep craters formed in the solar system's youth, and the vast, dark plains of carbon-rich soil. This light has traveled for years, sometimes centuries, just to touch the comet's surface. It is a connection across the void, a reminder that even in the deepest isolation, we are reached by the light of others. The gravity of the sun, though invisible, is the most reliable thing in existence. It is a tether that never snaps, a promise that the comet will never truly be lost. It is the same gravity that keeps your bed firmly on the floor and your world in its proper place. As the vastness remains vast, our own sense of self begins to merge with the environment. We are no longer separate from the night. We are a part of it. The boundary between the air in the room and the breath in your lungs is thin. The boundary between your mind and the quiet cosmos is even thinner. Somewhere within all of this, the specifics of our identity, our names, our jobs, our memories, become secondary to the fact of our being. We are the consciousness of the universe, resting for a moment before the cycle continues. The comet is a physical anchor for this feeling. It is a tangible piece of the infinite that we can understand, a mountain of ice that bridges the gap between the human scale and the cosmic scale. The repetition of the cosmic cycle is the ultimate lullaby. The comet returns to the Oort cloud. The Earth circles the sun. The stars consume their fuel and give birth to new nebulae. This is the infinite ending that is not an ending at all, but a transition. It is the point where the circle meets itself. You don't need to stay awake to witness the completion of the circle. The universe is a self-sustaining system of beauty and order. It is a clock that winds itself. Long after this moment passes, long after the sounds of the night have settled into total silence, the comet will still be there. It will be moving through the dark, a silent mountain in a silent sea, fulfilling a destiny that was written in the stars long ago. The concept of starting with something familiar is the way we keep our balance in this vastness. We look at the giant comet, but we remember the pebble in our hand. We look at the Oort cloud, but we remember the fog on a winter morning. We look at the 3 million year orbit, but we remember the steady ticking of a clock. These familiar things are the anchors that allow us to explore the infinite without drifting away. They are the seeds of the next cycle. In the quiet of the night, your mind can begin again. It can strip away the complexity of the world and return to the simple, familiar sensations of rest. The weight of the blankets, the rhythm of the breath, the softness of the pillow. The stars will continue to shine, the gravity will continue to pull, the vastness will remain vast. These are the 3 pillars of the cosmic night. They are unshakable, they are certain. As you surrender to the deep drift of sleep, you are placing yourself in the hands of these pillars. You are trusting the same physics that guides Bernardinelli Bernstein through the void. There is no safer place to be. There is no more natural state than this. The universe is cooling, the space is expanding, and you are simply moving with it, a part of the slow, quiet, endless flow of reality. You can let go now. The story of the largest comet we've ever found has served its purpose. It has given you a sense of scale, a feeling of perspective, and a path into the dark. The details of its discovery, its size, and its long, cold orbit can now fade into the background. They are no longer facts to be remembered, but colors in the landscape of your dreams. The mountain of ice is moving away, back into the deep drift where it belongs, and you are moving away, too, back into the deep drift of your own subconscious. The universe is large enough for both of you. It has plenty of room for your dreams and the comet's journey. And so, the universe continues. It does not need your permission. It does not need your attention. It simply is. And in that isness, there is the most profound peace we can ever know. The quiet continuity of the cosmos is the final answer to every question. It is the resolution of every tension. It is the infinite ending that allows us to begin again, over and over, with every breath, with every night, with every dream. The comet is out there, the stars are out there, and you are here, drifting safely into the quiet. As the narrative of Bernardinelli Bernstein recedes, we find ourselves at the edge of a great, silent ocean. The universe does not hurry its tides for our benefit, nor does it slow them down to match our heartbeat. It moves with a steady, cooling expansion that has been the background of all things for 14 billion years. The 85-mile-wide nucleus is just one pebble in this vastness, a dark mountain drifting through a sea of velvet. You can imagine the comet now, far beyond the reach of our atmosphere, moving with a grace that requires no effort. It is simply following the curvature of the dark. There is no ending in the way we usually understand it. In the cosmos, an ending is merely a transition into a new state of being. The ice that sublimates from the comet's surface doesn't disappear. It becomes a part of the interstellar medium, drifting until it is caught by the gravity of a new star or a new world. This cycle of gathering and scattering is the pulse of the universe. It is a slow, rhythmic breath that spans eons. You don't need to stay awake to hold the world together. The gravity of the sun is a permanent anchor, a silent promise that the order of the solar system will remain intact while you rest. The comet is moving now even as you breathe, drifting through the orbit of the outer giants. It is passing through the same physics that governs the rise and fall of your chest. The stars will continue to shine their cold light on the icy surface of the nucleus, and that light will remain steady. Across the immense distances that no longer fit neatly into numbers, the photons travel for years just to touch the ancient dust of the comet. This light doesn't carry the heat of the day, it carries the clarity of the infinite. It is a soft, silver glow that doesn't demand action or response. It simply illuminates what is already there. The vastness will remain vast. It is a space large enough to hold every thought, every worry, and every dream, allowing them to drift apart until they are as sparse as the atoms in the vacuum. In this state of infinite ending, individual moments begin to lose their edges. The 3-million-year orbit of the comet and the 8-hour cycle of your sleep are both parts of the same continuity. One is not more important than the other. They are simply different tempos in a single symphony. You can allow your mind to match the slower tempo. You can let go of the minutes and the hours, and instead think in the language of orbits and eons. The universe is a place of grand, slow movements and deep, restful silences. By aligning yourself with these scales, you find a certain peace in your own insignificance. It is a safe insignificance. It is the peace of being a single, quiet note in an eternal song. The comet does not care if it is observed. It does not care that we have measured its diameter or calculated its path. It is free from the burden of being known. You, too, can embrace this freedom tonight. You can let go of the need to be perceived, the need to be productive, or the need to understand. You can simply be. Like the mountain of ice at the edge of the sun's reach, you are a solid, stable presence in a universe that knows how to care for itself. The gravity does not tire. The void does not end. The laws of physics are the most reliable companions we will ever have. As we move toward the final dissolution of thought, imagine the comet reaching the furthest point of its journey half a light year away. It hangs there in the perfect balance of the Oort cloud, a dark monument in a garden of ice. There is no sound there. There is no wind. There is only the distant, steady glitter of the Milky Way. This is the ultimate rest. This is the destination toward which all things eventually drift. By bringing this image into your mind, you are inviting that same stillness into your own space. You are creating a sanctuary of silence that mirrors the deep reaches of the solar system. The isness of the universe is the final resolution. It is the acceptance that things are exactly as they should be. The comet is 85 miles wide because that is how it formed. It is on a 3 million year path because that is how gravity pulled it. You are here, resting, because that is what your body and mind require. There is no conflict in these truths. There is only the quiet continuity of the cosmos. Long after this moment passes, long after the last words of this script have faded, the universe will still be moving gently forward. The comet will still be falling through the dark. The stars will still be shining. Somewhere within all of this, we can begin again. Every night is a soft reset, a return to the primordial stillness from which we all emerged. By starting with something familiar, the feeling of the air, the weight of the body, the rhythm of the breath, we find our way back to the center. We are the consciousness of the universe, and tonight, the universe is choosing to rest. You are a part of the same atoms, the same story, and the same quiet destiny as the largest comet we've ever found. The vastness is not a place to be feared, it is a place to be shared. We share it with the giants, with the ghosts of light, and with the billions of years of history that preceded us. The night is deep, and it is kind. It offers a scale that makes our burdens feel as light as starlight. You can drift now. You can let the details blur. You can allow the infinite ending to carry you into the beginning of your dreams. The comet is out there, the stars are out there, and you are here, drifting safely into the quiet. The universe continues. It simply is. And that is enough. Moving gently forward. Long after this moment passes, the vastness will remain vast. And somewhere within all of this, we can begin again by starting with something familiar. Good night.